So this is a synthesis problem, which means you don't have to draw the whole mechanism, though you do have to know how the mechanism works in order to predict the products. So all you really have to do is to draw the major product. And so when you do that, you are really thinking about two things. What are you adding? And where are you adding it? You might also think about how you're adding it in terms of what direction the atom, the nucleophile, is going to add on to this molecule. So what is given to you in the reaction lists I made? For each reaction, you'll have to recognize the reaction based on the recipe that's given to you, and then you'll know, oh, in this one, this is hydrohalogenation, you add the hydrogen and a halogen. Then where do you add them? Well, this where and how will have a lot to do with the notes that are next to the reaction lists, next to the reactions on the reaction lists. So for example, next to this reaction of hydrohalogenation, on the reaction list, you'll notice there is Markovnikov addition. So, Markovnikov. So hydrogen to less substituted carbon. And the other thing is that this can have rearrangement. It won't always have rearrangement, but you have to watch out for it. Finally, the how. Now, in future reactions, the type of things you might have to look for here is syn addition, S-Y-N, or anti-addition, A-N-T-I. We'll talk about those when we come to reactions where you have to worry about them. But for now, the thing you should realize is if you don't see syn addition or anti-addition in those notes next to the reaction, you don't have to worry about those. But what you should realize is you will always have to worry about chiral centers. Now, you should always ask yourself, do you have one? Do you form one? If you do form a chiral center, then you will have a racemic mixture. Remember, that means you have a 50-50 mixture of the two enantiomers. So because you form a carbocation and carbocations are flat, the nucleophile will attack with equal probability from the top and from the bottom. And so you would get 50% R and 50% S. And if you don't have a chiral center, then you don't have to worry about that. So you don't have to do anything special if you don't have a chiral center. Excuse me. So those are the sorts of the three things you really want to watch out for. What are you adding? Where are you adding it? And what direction is it adding in, or how is it being added? So in this one, you look at this reaction. Now, one thing you have to do before you can solve these problems is you have to know these reactions. There's no way around it. If you don't know the reactions, then you won't be able to tell what you have to add. It'll be really confusing to try to figure out where it's adding if you don't even know what the reaction is. And details like chiral centers will be hard too, because you don't know what or where things are adding. So what do you mean, chiral center, 50-50 mixture? So studying for these problems is really a two-step thing. First, you have to memorize the reactions. There is no way around that. And second, you have to apply them. Applying them is what you have to do on the test. So memorizing them, even though it's a lot of work, it's not enough. But you want to make sure you give yourself plenty of time. You start memorizing early, because once you've memorized, you still have a whole other step, which is going through this thought process and applying those reactions to specific problems. Okay, so now that we have these things down, we can take our molecule and we'll just duplicate it here, and then you always get rid of that double bond. That's the extra glue you're using. And be careful about the two atoms in the double bond. Unless you have rearrangement, the two things you add will always be on those two positions. Now, notice one of these is tertiary and one of these is secondary. So we know we're adding an H and a Cl, but where does the H go? The H goes to the less substituted carbon, because this is Markovnikov addition. And so the H is going to go on this secondary carbon. So we'll erase that double bond. Those electrons are going to hold on to that H. Now at this point in the mechanism, and we don't have to draw the mechanism out, but we have to understand that at this point in the mechanism you would have a carbocation. And you have to ask yourself, will that carbocation rearrange? It's tertiary. Next door, there is primary, secondary, and secondary, so that carbocation is already on the most stable position nearby. So it's not going to rearrange. And so the other thing we're adding, which in this case was the Cl, is going to add on that position that had the most stable chlorine. Now we don't have any chiral centers here, so we don't have to worry about doing anything special. We can just draw the chlorine there. And if you drew this as your answer, I would totally accept that. In the future, as you practice more and more, you might try erasing that hydrogen at the end, because hydrogens are implied in the skeletal structures, so they're not drawn explicitly. But as you're first starting, you might even want to draw the hydrogen, just so that you can tell the two things you've added, where they've added, and how they've added. And so that would be the answer for that one. You can see that as you get good at doing these, it doesn't require a lot of drawing, so as you get good at doing these, you should be able to do them in around 30 seconds or so. You'll sort of know that you've reached enough mastery if you can do them that fast. Notice also the risk for these, because there's not that much work you can show, although this type of stuff is the work that you can show, that if you don't show this work, it's either all or nothing in terms of points. There's no partial credit if you don't show any work. So you might show this type of what, where, and how sort of work if you want to get partial credit on something like this. So let's go through that same thought process with another molecule. So again, you'd say, okay, this is hydrohalogenation. Right? You see a double bond, you see a hydrogen and a halogen. Those are the signs of hydrohalogenation. So you say, okay, with hydrohalogenation, you're adding an H and a halogen. It's not always going to be Cl, it just happens to be what they're giving you here. Could be Br, could be I, whatever they give you here. This is a Markovnikov addition, so hydrogen's going to go to the less substituted carbon. We have to watch out for rearrangement, and if we form a chiral center, we have to draw both enantiomers. Okay, so we'll copy this molecule. You're going to look at the two carbons in that double bond. Unless you have a rearrangement, that's where things are going to add, and look at how substituted they are. So this top one is primary, this bottom one is secondary. So where does the hydrogen go? It goes to the less substituted carbon. So we'll erase that pi bond. We're going to use those electrons to hold the hydrogen onto that less substituted position. Now you don't have to draw the mechanism, but you have to know that at this point you would have a carbocation on that secondary carbon. And you always have to watch out for rearrangement with hydrohalogenation. So we'll look at that secondary carbon, and nearby there is a tertiary position. So we will have rearrangement. Now we don't have to draw it all out, but ultimately the carbocation is going to be on that tertiary position. And so that's where the nucleophile is going to add. So when we draw the chlorine, we're going to draw it coming off of that position. That's not a chiral center. We don't have any chiral centers, so we don't have to draw anything special. And if you just drew that as your answer, that would be awesome. I would totally accept that. One thing you might try as you practice and practice and practice is just erasing that hydrogen at the end, because those are there, but they're implied on skeletal structures, so they're not drawn explicitly there. So that's a couple examples of how you might think through the synthesis, or the one-step synthesis of hydrohalogenation when they give you all of the reactants.